A2 is the second attribute, A3 is the second attribute, A4 is the next attribute, A5, A6, A7, A8, A9. For the modeling purpose, we have only considered A2, A9 only, because these are the attributes where we have already done the scaling of 1 to 10. Okay. So for modeling purpose, A2 to A9. In A10 is the target value. It is the target value. Now, suppose that we only divide this particular data in two parts. First is training part, and second one is testing part. For example, we divide this particular data from this particular segment. It means just a minute. Okay. Now we want to divide it. Okay. So I am considering 70% training and 30% testing data. We will discuss it, how you can perform splitting and which splitting is better, how you determine that this particular splitting is perfect for your model. We will discuss it. Here we fix it that for training purpose we divide 70% of the data, and for the testing purpose we can consider 30% of the data. Okay. So we divided it. This particular proportion or this particular data segment we have used, or we used for the purpose of training, and this particular segment we use for testing purpose. Now this particular segment belongs to A2 to AN. Suppose that this segment is segment 1, S1, and the target segment of S1, suppose that S1 bar. The second segment is S2, and the target segment of the second part is S2 bar. Okay. Now there are two divisions, S1 and S2. S1 is the training part and S2 shows the testing part. This particular part will be used as the sample data for training. Okay. Then it is submitted to your model. Model means any machine learning algorithm. Simple. Any machine learning algorithm. So we input this particular part, A2 to A9, as the training sample and input it to model. And it predict some value. Okay. This particular model is trained. This particular model is trained. Now, the next segments come in picture. If your model is created, the next segment is created. Then you can then we consider the S2 segment. The X2 segment is input to the model and test the accuracy and predict some value. If the predicted values are 0, 1, and 1, suppose that 0 for non-cancerous and 1 for cancerous. If the predicted values are also same, for example, 0, it means in our result, it is this particular patient is found to be non-cancerous. It means it is non-cancerous. If it is cancerous, our model also generate 1. In this case, our model also generated 1. It means the accuracy of our model is 100%, because first we train the model based on the training values. 70% of the values here we use for training purpose. Based on this, We have created the model, we have prepared a model. After that, we have tested that particular model on these particular segment, that is S2, and the machine predicts some outcome. Machine produce some outcome, or you can say it predicted some values, or it predicted some outcomes. If these particular outcomes are same, the result is 100%. For example, in case of 0, our machine produce 1, but in case of 1 and 1, it produce 1 and 1. It means out of 3, 2 occurrences are correct. It means 66.66% is the accuracy of our model. Like this, we can train and test the data. How training and testing will be performed, this particular aspect you can consider it. Okay, so the testing data is unseen for the model. Remember, the testing data is unseen for the model, and the results will be validated. And suppose that we are not getting good result, then you again retune, or again retune your parameters and hyperparameters. Now, the complete concept is that you have a sample data. Suppose that n equal to 70% of the complete data. Okay, your model, it means ML algorithm or any classification algorithm. Then suppose that if you are using linear regression, suppose that you are using linear regression. So we have already discussed it. It attempts to the model the relationship between two variables by fitting alike equations. Okay, it shows a linear equation. It shows a linear equation. So a function is generated based on linear regression. Okay, this function is generated. Suppose that f1 function is generated. Okay, based on the data sample, f1 function is generated. So in linear regression, it is equal to a line, or the function is a line. So if you apply data sample applied on that particular model, model will generate a function. Model will generate a function. This function is used to predict our future value. Then 30% of the data segment is used for testing. So the new data is the testing data, which is unseen data for this particular function, because this function was trained on this particular data. So when you want to predict with this particular function, this function is used to prediction, or this function is used to predict our function value. So based on the unseen data, or based on the test data, you can predict the value. So we will take suppose that different test values or attribute like a1, a2, dot a9. Okay, to the function to predict the patient is having cancer or not. For example, if you receive 8 outcomes correct on the overall 10 outcomes, then the accuracy is 80%. Then the accuracy is 80%. And suppose you are not satisfied that the accuracy is very low, then you retune the parameters or hyperparameters. Then now you have to calculate the new function based on the based on the retuning of parameters, based on the retuning of hyperparameters. New data is here. New data is called test data, but if you think that this particular model generates the accuracy of 80%, which is very low, our model should predict data on testing data, then you can say it is not a good response, and you again train the model. Again train the model. How you can train the model? Then the steps of machine learning, or you can say you did some modification in the model based on the attributes or based on the hyperparameters, and generated a new function. Suppose that that is f2. Then again test the data on f2. Suppose that you received you achieved an accuracy of 93%. You are again saying no, it is not good. this particular model is not good. The accuracy should be more improved. Then again did some modification in the model, did some modification in the accuracy tuning and hyperparameter tuning, again tune it. Then a new function is generated, F3. Then again test it. Okay, you will achieve, suppose that you achieve 97% of the accuracy on F3. Then you say, okay, now this is okay, or you can say now it is optimal, and this model is now prepared, or now you can test on different data segment. Now you can test different data sets. So here validation data is seen by the model during the training time. Here this particular data segment is testing. You have to validate here. First you train the data based on the model or any classification algorithm or ML algorithm. Then a function is generated. Then you should validate the data based on some proportion. For example, if it is 60%, then 60% of the portion or 60% of the data segment may be considered for training purpose and 20% for the validation purpose. Then validation data is seen by this model during the training time. After finding the best function, now you can apply the test data. So F1, F2, F3, this particular function procedure you can process in the training time only. This is the good habit, because in training time you consider you have developed your model, and based on some percentage of data segment you also validate your model, or you also validate your function based on some accuracy measures. If you think that it is optimal, then it is okay, then your model is ready for testing purpose. So remember, validation data is seen by the model during the training time. After finding the best function, now you can apply it on the test data. Okay, so you can see the validation set is the set of data that we do not use when training our model, that we use to assess how well these rules perform on new data. It is also a set, you can say, we use to tune parameters and input parameters for our model, so that it gives us what we think in the best performance possible for new data. It is also used to evaluate a given model, but this is for frequent evaluation also. You can say it is used to fine tune the model parameters, hyperparameter. We can say it can be used for the validation set results and update higher level hyperparameters, so that the accuracy will be better on different parameter, different performance measures. So the validation set affects the model, but only indirectly. Remember, only indirectly. Okay, because you only validate to improve the functionality of the function, improve the functionality of the function based on some training set, that is called validation set, after preparing the model. So the validation set is also known as the dev set or the development set, because it forms a clear view, clearer view for your functional aspect. This makes sense since the data set helped during the development stage of the model. Then the main role of your unseen data or test data is the we did not use to train our model or use in the validation set to inform our choice of parameter or input features. So what can you do? We will use it as a final test data decided on our final model to get the best possible estimate of how successful our model will be when used on entirely new data. The test data set also provides the gold standard used to evaluate the model. It is only used once a model is completely trained. Completely trained means using the train and validation set, because training includes the validation also. Okay, many a times the validation set is used as the test set, but remember, I do believe it is not a good practice. I think just train your model, and after that you should validate it. You should validate it again and again. You should validate it on basis on different iteration, basis on different epoch, basis on different threshold value, so that your function fit to the best possible optimum value. So uh, the test set is generally well curated. It contains clear carefully sample data that spans the various classes that the model would face when used in the real world. I think it is very now it is very clear that training and validation is very important part. After that, your model will become uh, prepared, or you can say it is prepared for the testing or for any unseen data, or for your model if you want to test it, the data should not be biased, should not be biased. It should be free from all biasness, so that you can really validate before launching your prediction platform, or launching your prediction framework, or launching your detection capability framework. Okay, so you can see, if you having different tasks like T1, T2, T3, T4, T5, T6, T7, and based on that, this is the target sample, or you can say T1, T2, T3, T4, T5, T6 tests are also called attributes. So based on the attributes, suppose that we want to determine that this particular patient, or this particular person is cancerous or not. Okay, so you can model your task in train, validate, and test. Okay, and suppose that this percentage is 60%, this is 20%, and this percentage is 20%. So 80% data you can use for training and validation, and 20% of remaining data you can use for testing purpose. You can also divide 70% of the training, 70% of the data for training purpose, 30% of the data for testing purpose. We will discuss the splitting of your data set in train, validation, and test set further. But for example, we will just consider a normal consideration by different researchers, 70-30 or 80-20%. Okay, based on that, you can train your data, then validate it, and you can launch for the testing purpose. Then, what is model parameter? We've already discussed that we can retune, or we can did some changes or modification, or we retune parameters and parameters. What is model parameter? So model parameter is a configuration variable. It is a configuration variable that is internal to the model, and whose value can be estimated from the data. Values must be estimated from the data. It is the internal part. They are the part of the model that is learned from historical training data. For example, by considering X, automatically Y is associated. For example, if you are or if you are taking alcohol, the chances of smoking is high. So if X is present, Y is associated with it. So these particular parameters uh, can be called as internal parameter, and it is the part of the your integration model, or your hybrid model that is learned from historical training data. So it required by the model when making prediction. It is also define the skill of the model on your problem. It also estimate or learn from data. They are often not set manually by the practitioner. They are often saved as a part of the learned model. In terms of statistics, you can say you may assume a distribution for a variable such as Gaussian distribution. You can say if you consider two parameters of the Gaussian distribution, you can consider mean and standard deviation. So these are the internal parameters. Okay. Then programming. In programming, you may pass a parameter to a function. In this case, a parameter is a function argument that could have one of a range of values, like two of the parameters accept the values from 1 to 10. Okay. So in machine learning, what you are using is the function, and require parameters in order to make a prediction on the new data. So internal parameters are very important, and it also learns from the previous history or the historical training data, or it is used in the prediction of the it is used for the prediction of the model. It is also defines the skills, and it never set manually, because if you set manually, then what is the need of training the data? It should be automated. The process should be automated. What are the model hyperparameters? These are the external parameters. External parameter is called hyperparameter. Based on that, overfitting and underfitting will be defined. We will discuss overfitting and underfitting in the next session also. So a model hyperparameter is a configuration that is external to the model and whose value cannot be estimated from the data. They are often used in process to help estimate model parameters. They are also specified by the practitioners. They can often be specified by the they are tuned for a given predictive modeling problem. We cannot know the best value for a model hyperparameter, but based on the equation, based on the problem scenario, based on the search value, based on the previous trials, based on that, you can also